Assalamualaikum and good evening. This is our subject DJJ6182, which is engineering blank. The title for our case study is Impulse and Reaction Steam Turbine. We are from Group 5 and this is our slide presentation for part 1. Our lecturer name is Kirizam bin Makhir and our group member is Muhammad Adam bin Rosli. The metric number is F2013. Second, Muhammad Luqman Hakim bin Muhammad Suranto, Astrofi Khairul. The metric number is F2014. And the last one, me, Fadira binti Muhammad Tamizi, and my metric number is F2016. This is my group members. The first one is Muhammad Adam, and the second one Muhammad Luqman, and the last one me is Fadira.
History of steam turbine. Sir Charles Argyll Parsons is an Anglo-Irish engineer. Its modern manifestation was invented in 1884. The first model of steam turbine is connected to dynamo in 7.5 kilowatts of electricity. The turbine, in which thermal energy of the steam is first converted into kinetic energy and later converted into mechanical energy, are called as the steam turbine.
Okay, let's proceed to introduction. So, we go to the next slide. A steam turbine is a device that extracts thermal energy from pressurized steam and uses it to do mechanical work on a rotating output shaft. The steam turbine is a form of heat engine that derives much of its improvement in thermodynamic efficiency from the use of multiple stages in the expansion of the steam, which results in a closure approved through the ideal reversible expansion process. Because the turbine generates rotary motion, it is particularly suited to be used to drive an electrical generator. About 85% of all electricity generation in the United States in the year 2014 was by use of steam turbines. A steam turbine connected to an electric generator is called a turbo generator. Operation principle. The steam turbine, unlike the reciprocating steam engine, which operates due to the pressure energy of system, operates due to the dynamic action of the steam. The acceleration which may be a change in either magnitude or direction of a stream of fluid produces a turning moment on a rotating shaft. In a steam turbine, the velocity of steam is increased at the expense of pressure by passing the steam through a set of nozzles, and this high-velocity steam, when allowed to impinge on a series of moving blades fixed to a common shaft, produces the shaft foot. The velocity of steam may be partly increased in the passage between the moving blades themselves. There are two principles through which the turbine operates. They are, for the first one, impulse principle, and the second one, reaction principle. I will pass to the Muhammad Adam to explain about working principle of impulse and reaction. Thank you.
Hello, my name is Muhammad Adam bin Rosli. My metric number is 01 DKM 18F 2013. Okay, for my part, is working principle. They have a two impulse turbine and reaction turbine. Okay, first that we focus on working impulse turbine. On the diagram, impulse turbine is made of casing, nozzle and run of 8 blades. Nozzle regulator the steam flow and guides the steam to flow at appropriate velocity as the high pressure steam. The steam of completely converted into the kinetic energy This velocity of the steam is very high. The steam flowing through to the nozzle is called as a jet. This high velocity jet is deflected on the blades mounted on the runner resting molecules. Apply the force on the surface of turbine. Blades due to this turbine runner and shaft starting rotating. This shaft is also connected with the generator. Therefore, generator rotates and the electricity is produced. Okay. Next, let you can see the details of turbine. The diagram shows its principle behind the working of impulse turbine, and this turbine steam pressure remain constant while following through the moving blades. The velocity of this steam is very high while following through the nozzle, and its decrease while following through the moving blades. That for impulse turbine. Okay, next, let we see reaction turbine. In this turbine, the nozzle are attached with the guide wheel. This nozzle converts some part of the pressure energy into kinetic energy. This steam following through the nozzle is called as a jet. This jet is passed through the moving blades with pressure and kinetic energy. The steam molecules exert the force on the blades. On this causes the turbine runner and shaft to rotate. This shaft is also connected with the generator. Therefore, generator rotates and the electricity is produced in reaction turbine. Like we can see in the diagram, the steam pressure fall gradually, where is an impulse turbine is constant while following through the blades. On the reaction turbine, the velocity of the steam decreases while following through the moving blades. That's for reaction turbine.
Hello, my name is Nafadira binti Ahmad Tamizi and my metric number is 01DKM1AF2016. Okay, I will show you the diagram or figure of impulse and reaction turbine. So let's see. For the figure 1, this is figure of impulse and reaction turbine. Figure 2, this is figure of the principle of impulse turbine. The last one, figure 3, this is figure of the principle of reaction turbine. That's all from me. Thank you.
Hello, my name is Muhammad Lukman bin Muhammad Siantul Niskeru. My metric number is 01DKN18F2014. Summary: turbine blade and his turbine having this type of blade are classified as impulse or reaction when moving blades are driven entirely by the effect of an external jet impinging upon them. They are known as impulse blades. When the fluid in the moving blade accelerates and lifts the blade at a higher velocity than when in interior them, it imparts a jet reaction to the blade, making this reaction blade. With reaction blade, there is however always some impulse effect as the fluid enters the moving blade, so such blade have only a degree of reaction which is commonly 50%. Condition in turbine blade can be conventionally visualized and analyzed by drawing vector diagram of the fluid velocity. Such velocity diagram corresponding to the inlet and outlet of the moving blade show clearly how the fluid kinetic energy exchange within the blade. Essentially, the loss in kinetic energy of the fluid is equivalent to the transfer of energy to the blade. There are, however, limits to the amount of energy that can be transferred. The fluid must flow away from the blade with a certain velocity to make way for more fluid, so the blade efficiency can never be 100%. Furthermore, there is always some frictional loss in the blade, so the stage efficiency can never be 100%. Nevertheless, modern steam turbines are very efficient and operate with internal efficiency within the range of 80% to 90% depending upon the steam condition. Thank you.